So this is our ABRA Learning How to Solder Kit, and it's available at abraelectronics.ca. It's under $30 for the kit, and to it I've added a few things, so I just wanted to show you what comes in your kit when you get it. So when you open up your box, you're going to find a ABRA LED flasher kit, and I've prepared a separate video on just doing this board. And inside you're going to get a soldering iron. You're going to get a pair of side cutters, a tube of solder, and a soldering iron stand. You're also going to get a larger piece of perf board and a set of resistors that you're going to solder into the board. And you're going to get a smaller piece of perf board and a few ICs that we're going to solder into it. You're also going to get two booklets. One is called ABRA, Learn How to Solder Kit, and the other one is called Soldering is Easy, Here's How to Do It. To your kit, I like to add a desoldering pump so we can practice desoldering those resistors that we're going to solder in. Also some solder wick that we'll use to desolder the ICs that we put in. A pair of needle nose pliers are always handy. And 3 drill bits. 2 of the drill bits are 1/32 in size. The other one is 3/64. I chose these sizes because they're easier to pick up at home hardware. Don't forget that you're going to need a small flat-bladed screwdriver, so hopefully you kept your ABRA screwdriver from your first year parts kits. As with all my projects, I give you the marking sheet. So this is for learning to solder, lab number 2. We can see if you keep this sign-off sheet clean, flat, no bends or creases and no stains, you'll get 1 mark to start with. This entire project is out of 20. We have exercise 1 with the perf board. We need to solder all 40 resistors into the board and get it signed off. That is worth 1 mark. Then we're going to desolder all 40 resistors and get your board signed off again. That's another mark. Exercise number 2. With the second piece of perf board, we're going to solder all the ICs onto the board, and that's worth a mark. And then we're going to desolder the ICs from the board, and that's worth another mark. Then when we start working on the LED flasher, if we trim our board and smooth the rough edges, that's worth another mark. So that's worth 5 marks of the 20. Then moving on to the LED flasher, we're talking about the soldering here. And you can see if there's no untinned copper, you get a mark. No excess solder, you get a mark. All joints fully soldered, worth a mark. No missing solder pads, worth another mark. No missing traces, worth another mark. So the total for soldering is worth 5 marks. So now we're up to 10 marks out of the 20, and you haven't even got the board working yet. Still talking about the LED flasher board, we're now talking about component placement. So if all your components are flush with the board, that's a mark. All components oriented in the consistent manner, another mark. Components properly placed, another mark. And trimming your leads, that's another mark. So that's another 4 marks. Then we have to install a battery cable, and providing you've installed that correctly, without melting the leads, that's worth another mark. Now making sure the LED flasher actually works, that's only worth 4 marks of your total project. So the total project is out of 20. Every time you need a replacement part, you're going to lose a couple of marks. And if we have file folder notations, you're going to lose a mark. And if you miss a signature, you're going to miss 2 marks. Please note, any project submitted for grading without the mandatory sign-off sheet will result in a grade of 0. Sign-off sheets placed in your file folder will result in your project being graded. So don't try keeping your marking sheet in your file folder. If it's a 2 or 3 week project, you do have to keep it with you. So I recommend you get a duotang or a notebook of some type to keep it flat and smooth. So on the other side of your marking sheet is the mandatory sign-off sheet. So the first thing you're supposed to do is to check and ensure that the kit is complete before starting the project, and you, the student, must sign it off. So the first thing you're going to do is put your student name on here, and then check your kit to make sure it's complete and sign that off. Because if you come to me later saying there's parts missing, after you've signed it off, I'm going to deduct 2 marks for each part you have missing. So we have a sign off here for having exercise 1 Perf Board engraved by the instructor or technologist for identification purposes. The next sign off is to be checked by the instructor or technologist when the first row of 4 resistors have been soldered in. That's not all the resistors soldered in, that's not 2 rows, that's the first row only. Then we're going to check it again when all 10 rows of the resistors have been soldered in. Then we're going to check it again when all 10 rows of 4 resistors have been desoldered. This gives us a chance to give you feedback on how your work is going. Then we're going to have exercise 2 Perf Board engraved by the instructor technologist for identification purposes. Then you're going to solder in your first IC so that we can give you some feedback. Remember, it's your first IC. It's not all ICs soldered in. It must be just your first IC. Then it's checked by instructor technologist when both ICs have been soldered in. And then checked again when both ICs have been desoldered. Now, a lot of times students will bring their work up to us to ask us how they're doing, and we'll give you feedback on how you're doing, but it's up to you to bring the sheet up and have us sign it off. We can't remember half hour later that, oh yes, you showed us 1 IC soldered in. So it's your responsibility to bring the sign-off sheet up with you when you need those sign-offs. Moving on to the LED flasher board, we're going to get it engraved by the instructor or technologist for identification purposes. Then there's a sign-off for check by instructor technologist when LED flasher board is populated by all polarity sensitive components before soldering. Please keep in mind this is before soldering. So what are polarity sensitive components? ICs, IC sockets, capacitors, LEDs, those are all polarity sensitive. Then we're going to give you some feedback when at least 3 and no more than 5 components are soldered to your board. That's not the entire board completed, that's just 3 to 5 components. And please bring in 3 to 5 different components, such as a resistor, an LED, an IC socket, or a capacitor. Don't bring us 3 or 4 LEDs soldered in, we'd like to give you some feedback on the different components that you're soldering. Then the last sign off is when you demonstrate it to us, showing it working. Okay, the speed of the lights must be proven to be adjustable. And notice we have space underneath for replacement parts. So every time you need a replacement part, you're going to lose a couple of marks. I just want to bring to your attention this bottom warning here that all projects must remain in your project box until graded. Violation of this policy will result in a grade of 0. Because we're going to be working on this project for several weeks, we don't want you taking it home and perhaps having an uncle in the industry doing all the soldering work for you. So the project must remain locked up here at the college. So the first thing we're going to do is assemble our soldering iron stand. Some people have some problems assembling these, so I'm just going to go over it with you. Take all the parts out. That's the sponge. Okay. This is the base. This is actually the holder, and you can see that the holder goes on like so, and we need a screw and a wing nut. So that comes in this little bag. Sometimes they don't come in a bag and they're loose and you have to kind of find them. So break your bag open and don't drop these parts, because one thing happens is a lot of people lose these wing nuts. You can see it's a nut with wings on it. And this screw here, they're not our standard 440 screws. So if you lose the wing nut, it's really hard for us to find another one for you. Okay. So put the base down and the holder, and the screw goes in. You can either put the screw in from the top and put the wing nut underneath, or you can put the screw in from underneath and put the wing nut on top. Doesn't really matter. So then flip it over and put your wing nut on. Now the wing nut, you use wing nuts because you want to be able to take this apart. So it just needs to be finger tight. Okay. Okay, so make sure that this little bar goes between the two ridges. Okay. And this part here is for your sponge. And what you're going to be doing is you're going to be taking your soldering iron and wiping it on the sponge. Now the problem is the sponge is going to burn unless you wet it. You can see that it's a very, very thin sponge, so it's going to burn very easily. So what I do is every lab I bring in a bucket of water. So I've got a beaker of water here. Take your sponge and actually drop it in the water, and you can see that it just kind of floats there, and there we go. When you pull it up, it's going to drip a bit, so you don't want the excess water in there. You need the sponge to be wet, but you don't want it dripping wet, because you don't want to puddle all over the floor. Okay? And if you spill water on the floor, please pick it up. We put paper towels. Okay, so drain the sponge off, and now you can see right that your sponge is a lot thicker than when it first started. When you wipe your soldering iron tip, the hot soldering iron tip on here, it won't burn the sponge. So now we have, and you notice it's a lot larger because it soaked up the water. Okay, so you don't want this tray to be filling with water, but you want it to be a little damp when you take the sponge off. Okay. So the next item I want to cover is your soldering iron. There's many different styles of soldering irons. These are obviously a cheap $10 type soldering iron. When you open it up, you can see that it has a lead on there that you need to plug in. It has the handle which you hold, so you just kind of hold it like a pencil. This particular soldering iron has a tip with a coating on it to protect it. Most soldering irons have a nut on the end. It's usually just placed on finger tight. You don't want to put it on with a wrench. Okay. This particular soldering iron also has a screw in there to stop your bit from rotating. So I just want to show you this. Just going to loosen it up and your tip should be able to slide out. So these are replaceable. These are ironclad tips. I just want to show you the makeup of them. So this is the typical makeup of tip construction, and you can see in the center here we have a copper element and some kind of iron around it, some chromates and some tin. Now this is important because sometimes these tips get very dirty and need to be cleaned, and you just can't take a file to it and file the edges off. It will damage the materials that they're made of. So I wanted to point that out to you. So it slides back in there, and then the nut goes on, and then the screw tightens up. Not all soldering irons have this screw on here. Okay. Now this is the tube of solder that you've got in your kit. You can see, just pull it out the end here. I have replacement solder. It comes in a large spool, and it's from ABRA. Fluxing core. Okay, and it's 0.8 millimeters in diameter, and it is lead or tin lead, 60-40. So 60% tin, 40% lead. They mix the two metals together and it gives it a lower melting point. Make sure that when you buy solder, if you go to somewhere like Canadian Tire, make sure it's fluxing core. You don't want aciding core. Aciding core is for plumbing, and if you use that on your circuit board, it will just eat through the copper and all your parts will just fall off. Comes in a 1-pound spool. So this would be somewhere around $50 that you're looking at right here. Whereas a small spool like this is about $1. So on the back of your soldering iron, there's a set of instructions here: how to solder, clean the parts to be joined, that kind of thing. There's a caution here, and it says when the soldering iron is plugged in for the first time, there comes out smoke from the tip end. The smoke stops in a short while and smoke never comes out again. Use soldering stand and other aids to avoid burning fingers. Don't pull the soldering iron tip outward and use it. It will shorten the heating element life, so make sure the tip's all the way in. After finish the works, after finish using it, I guess, cool it down naturally. Don't stick it in a bucket of water. A lot of times students are in a rush to get out of the classroom and they come along and stick it in a bucket of water. Don't do that. It's going to destroy your soldering iron, and probably the next week it won't work. Okay? Don't file the tip face. Okay, so I already covered that because the different metals that make up the tip, right? Do not apply too much solder unnecessary, and clean the soldering tip. Alright, so here's the tip when you first see it, and I've never seen this before, but this one has that red coating on it that they kind of mentioned on the cover is going to smoke for a while. First time I've ever seen it on a soldering iron. Most of the soldering irons I get in don't have this coating on here, so they don't smoke. I've still got it with the tie wrap on here, so I've never plugged this iron in before. So I want to show you what happens the first time that you plug an iron in. This is a 2-prong iron, which means the tip is not grounded. Okay. If you get one with 3 prongs on there with the ground on there, the ground is hooked up to the metal and the tip is grounded. Okay. So typically what you do is you throw these things into your soldering iron stand. So it just goes in there, and then you just come along here and you just plug it in the wall. Okay, so I've got it in my soldering iron stand here. It's going to take a while to warm up. Probably, I don't know. So I'm going to wet my fingers. If you wet your fingers and touch something, I just heard it sizzle, so it's heating up pretty quick. But I still got this coating on the end here. I don't want to touch it because it's going to be too hot for my fingers here, but hasn't started to melt yet. I'm just kind of sitting here waiting for it to kind of start. The first time you use an iron, you can't rush this process. You just kind of have to stop and wait for it. And I'm going to keep the video rolling because I want you to see this. The other thing that you're going to need is your solder, so pull some solder out and make sure that you have it ready to go. And nothing's happening yet. Oh, looks like it's just starting to melt now. Okay, so I took my little screwdriver and I'm just moving that plastic coating around a bit. Okay. And you notice the coating's turning black now. It was red, so it is now black. And that was just a protective coating on the end of the tip there. And I can just see smoke starting to come off of there. So it's just starting to smoke off of there. I can just start to see some smoke coming out. You can see it's just burning off of there, and then off it comes, just like that. And right now, you want to get some solder on there. You want to get the solder on there immediately, okay? Okay, now, I don't know if you can see it clearly, but you can see the solder sagging a little bit. So it's melted on, and it's sagging a little bit. It's smoking a little bit. Because remember, this is a rosin core solder, so the rosin that was in the solder is kind of melting and burning off. And there it is, it stopped smoking. This here is molten metal, okay? And you can see it's right on my screwdriver tip here. You can see it melts quite easily. Okay. Now, if I'm not going to use this right away, I'm going to stick it into the soldering holder stand. Please notice I did not clean that off. Now this cable here, right, is getting very close to my holder. So I'm going to spray it out a bit and try and make sure that it doesn't touch the hot element, right? So it's very important this cable doesn't get near the hot part, or else you'll melt the cable. Okay. Now, if I'm ready to solder something, you can see the end of that tip does not look too clean. So before I actually do some solder work, I would come along and I would clean the tip off on the sponge. Don't leave it on the sponge too long because it cools the tip down. Okay, so now you can see the tip is nice and shiny. Now it's extremely important that you don't leave the tip dry. Okay, so put a little bit of solder on there. It's going to melt. Okay, you've got solder around the tip there. Okay, so make sure you've always got solder on the tip. I can't stress this enough. There has to be solder on the tip. Right now that solder is protecting the tip. Okay, so when you want to do some solder work, you clean off the tip, apply a tiny little bit of solder, and then do some soldering work. When you're done, make sure that you've left some solder on the tip to protect it, and then put it back into the holder. Then unplug it from the wall and let it cool down naturally. So leave it over there. It'll probably take maybe 10-15 minutes to cool off, and then you can put it away in your backpack. So in your kit you got two sets of instructions. This is soldering is easy. Here's how to do it. It's kind of a comic book type thing. It's very informative. Tells you everything you need to know. It's got full instructions on soldering, how to put parts in. The best solder for electronics has rosin core and is 60% tin, 40% lead. Safety tip. Okay, lead is poisonous. It gets on your skin when you hold the solder, so wash your hands after soldering. Very important. Okay. I like safety tip number 1. If you touch the tip, you will let go very quickly. Of course, the soldering iron gets hot, so this is the tip end. Please don't touch it. And it talks a little bit about electronic circuits and putting components into a board. How to clean your tip. Comes along here, time to actually solder. How to put the component lead through and bring your tip in. So you're going to bring your tip in on one side, the solder on the other side. Tells you now put the soldering iron back in its stand while we're not using it. The stand keeps the hot iron safely on the table. Most people say it is not fun to have it land in your lap. So this is a good set of instructions. I like them. And definitely worth reading. The second set of instructions that you've got are ABRA Learn How to Solder. It's got a picture of the kit, and like I said, this is your basic soldering iron, a pair of side cutters. So like I said, some years you get blue handled ones, sometimes you get red handled ones, and in the picture you've got a pair of black handled ones. To this kit I add needle nose pliers because they're very useful. And you notice there's a spring in the middle, so they always spring open. It makes it easy to do things with one hand. I include some solder wick with your kit, often called solder braid. So if you take a look at it, you can see it's kind of a braid in there, and it's used for sucking solder off the board. So I'm going to show you how to use that. It's not in the instructions. The other item that I add in there is the desoldering pump. That's not in the instructions either, so I'm going to give you a little tutorial on how to use that. And drill bits. You're going to need those later when we have a project called the Sumo Bot, and you need to drill the holes. Okay. So in these instructions, we're actually going to do these exercises, exercise number 1 and number 2. So I'm going to go through detail with you on how to do that. Okay, so we're going to do exercise 1. This is with the large board and the 40 10K ohm resistors. If you don't have 10K, any resistor will do. We're going to insert 4 resistors in a line separated by 1 mounting hole. So we have a little close-up picture here of what they want us to do. So as you can see, I have my soldering iron plugged in, and this is going to be my large board. So I'm going to start with this board. This one is my smaller board. So this one I'm going to mount the ICs to. This one I'm going to mount the resistors to. The first thing that we're going to do is we're going to engrave our name on the board. So I want everybody to engrave their name on the board so we know this is your board. This is my engraving tool. We have an on-off switch. We have a depth of engraving, so just put it about halfway, put it about 3.5, something like that. And the pointy end is what we use for actually engraving. When I turn this on, it's going to make a lot of noise. You just need to press not too hard, but fairly hard. So I'm going to show you how to engrave your name right now. So there's my name engraved on the board. Step 1 completed. I also want you to engrave your name on the smaller board. We don't have too much space on the back side, so we can flip it over and engrave our name. There's my name engraved on the smaller board, but we're going to do the component side rather than the solder side because they haven't left us much room. Our resistors come on this tape spool, and we need to take the resistors out before we can solder them in. So I'm just going to take the first 4 resistors out. These copper pads are the side we solder to. So if you flip your board over, these holes here are where we put our components in. If we take a close-up look at the instructions, we can see we put 1 resistor leg in. It goes over 2 holes, so it goes in the 4th hole. Then we're going to leave a space and then put the next resistor in over 2 holes and then follow the pattern. So I have my resistor here, and I'm just going to bend the leg over at either end and place it into the board as shown in the instructions. So I want 2 holes separating my 2 leads. Now I've got my first resistor placed into the board, and you can see it goes in the first hole, 2 holes underneath the resistor, and there's the 4th hole. The next resistor will go in this hole right here, and notice I've got it set up so I can read it from left to right. So it's brown, black, orange, gold. So the next resistor that I take, I need to orient it the same way around. Bend the legs over. So I've bent the legs over, and I'm putting it in the next hole over. So you can see that this one is brown, black, orange, gold, followed by a space, and then the next resistor, brown, black, orange, gold. And then don't forget to go underneath and spread these legs out. If you spread the legs out, the components won't fall off the board. My next resistor, whoops, this is backwards. Turn it around so it's brown, black, orange, gold. Bend the legs over. Put it in the next hole over. Turn it over. Hold it with your finger. Spread the legs out so that the component doesn't fall out. Turn the board over, and now the fourth resistor. Orient it the right way around, bend the legs over, and place it in the board. Push it down all the way underneath. Spread the legs out. Now there's one thing I want to mention. You want these resistors to be oriented the same way around, so that whenever you pick up a board you can read the resistor values without turning the board back and forth. The other thing I want to mention is that when you put a resistor in, you want it as flat to the board as possible, because the solder that goes underneath actually holds the resistor down onto the board, and this makes a mechanical connection. So it's not just electrical, it's also mechanical. And if you have a resistor, say for instance we had one of these resistors standing up like so, if somebody was to come along and press on this afterwards, it would break the electrical connection underneath. So this is a diagram of a good soldering joint, and you can see that it's curved as it comes around here. It's curved on all sides. The solder flows all the way around the pad, and the pin sticks straight up. Now they've cut the top off of this pin, but typically the pin would go further up. So this is an example of a good solder joint. I'm going to show you how to produce one of those now. So I've turned my board upside down, and you can see that we have all our pins bent over so that the part doesn't fall out. This is not going to make a good solder connection. So what I'm going to do is I'm going to straighten my first pin. And now I'm going to take my soldering iron, and there was the tip. And it's just got all this stuff caked on there. So I'm just going to wipe it off on the edge of the sponge. Notice that the sponge does sizzle. And there I have a nice clean tip. Now I'm going to bring some solder in and put a little bit of solder on the end of my tip. Bring the tip with a little bit of solder over to the wire lead and the pad. Bring the solder in from the other side, melt a little bit on, and then lift the tip all the way up the pin. This will cause the solder to flow up the lead, leaving a nice concave shape on the bottom. So turning the board over, you can see that the resistor is slid down a bit. So what you're going to need to do is turn the board back over, and with your finger press on the resistor, reheat the pad, push the resistor through, and bring the tip back up. The one thing I want you to note about a finger is there's a fleshy part that burns real easy, and there's your nail. So if you push the resistor with your nail, you won't burn your nail, but if you push the resistor in with the fleshy part of your finger, it will burn. Now when you turn the board over, you can see the resistor is laying flat against the board. The solder is making the electrical connection. It's also making the mechanical connection, holding your resistor flush with the board. So I've soldered my first component into the board. Now these great big leads here are no longer necessary. So everybody asks me, how far back should you trim the lead? And you should trim the lead just to the top of the solder connection. Now what I'm going to do is I'm going to place an IC right beside my resistor. What I've done is I've placed an IC beside the resistors, and I'm just doing this to illustrate a point. When you turn the board over, you can see the height of the pins from the IC that I've put in, that's about the height that you want to trim off the lead for your component. So they're going to be, it looks like they're not quite a 1/4 inch high. Okay, so that all your pins are the same height all the way across your board. So I'm going to take that IC out now. That was just for an illustration. So now I'm going to go through here and I'm going to solder each of the other 4. Now, because all these resistors are the same height, I can actually unbend all of the leads so that they're sitting straight up. Pressing the board down. Now the board's a little bit light, so you might want to throw a pair of needle nose pliers on there just to hold the board down. I'm going to clean off my soldering tip. Put a little bit of solder on the end of the tip. And then I'm going to come along and I'm going to solder the next pin. So heat up the pad, the pin, add a little bit of solder, run the tip up the lead. Come over, do the next one, heat up the pin and the pad, put a little bit of solder, run the tip up the lead. Come over to the next one, heat it up, run the tip up the lead. Next one, heat it up, put a little bit of solder in, run it up the lead. Next one, heat it up, bring in some solder, run it up the lead. Next one, heat up the pad and the pin, bring in the solder, and run it up the pin. Kind of like a little production line as I went along, right? So, there's a look at them. You're trying to get that nice concave look on it. You want to make sure that there's no holes around it. You don't want to overheat it because then the pad will fall off. Alright, so now I need to trim off the top of the pins. And how high should the pins be? Well, I said that they should be, if I bring my IC and put it into the board here, you can see that the pin length on the ICs, you kind of want all your pins across your board to be the same height. So about a 1/4 inch, which will be just above where the solder concaves into the lead. Okay, so just about a 1/4 inch up. Okay, so just at the top of the solder joint. So when you bring your side cutters in to cut these leads, the lead's going to go flying off into the air and could hit somebody in the eye. So hold on to your lead or put your hand over the lead. So I like to hold on to the lead and just snip it off. Okay, that one looks like it's a little bit high, so I'm going to snip it a little bit lower. Just put your finger over there so the little piece doesn't fly off. So that looks like an appropriate height. So I'm just going to go along and do the other ones. Hold on to the pin so it doesn't fly off. Put it to one side, and then the last one. Pin to one side. Okay, you notice I've got the heights pretty similar all the way across. I've got some fairly good solder joints in there. And when I turn the board over, you can see that all the resistors are flush to the board. Because if a component is sitting above the board, when you push on it and wiggle it, it'll break the pads off the board on the underside. So at this point, take this up to your professor and have him check off your mark sheet, and then repeat this exercise for the next set, and then the next set, and the next set. So we're going to put all 40 resistors in. There's 4 in a row, so we need to do 10 rows across. So once you've got your board signed off for having that row done, you can do the next 9 rows yourself. I'm going to leave 2 spaces between my resistors, like so. Please notice that they're still oriented so that I can read it from left to right. So brown stripe, black, orange stripe, gold. And I've left 2 spaces here. I think that'll work out along the length of the board. Now that I have my 4 resistors placed in the board, I'm going to solder them into place. I'm going to throw something heavy on the top of my board just to hold it in place. Clean off the tip. Apply solder to the tip. Bring the tip to the pad in the leg. Bring the solder in. Watch it melt. Bring the tip up the leg. And put your soldering iron back in the stand. Now at this point it's very important to turn the board over and make sure that all your resistors are flush on the board. Turn your board over and then trim all the leads off. So try and get a consistent height. Remember to hold on to the pin so that it doesn't go flying through the air. So you're trying to get a consistent height between the first row and the second row and all those pins beside it. So now that you've got 2 rows done, repeat this for the next 8 rows. All my resistor leads are now in a nice pile. I don't have to sweep up the floor and try and find my resistor leads. So I put my resistors in 1, 2, 3, 4. So there's 4 in a row, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. So now you can bring this up to your professor, show him your good work, he'll sign off your page. This exercise has taken me just under 45 minutes to complete. Now that you've finished this part of the exercise, I want to introduce you to a new tool. This is called a desoldering pump or a solder sucker. We have a tip end down here and we have a plunger here. So what you do with it is you press the plunger down till it goes click, and it holds the plunger in place. There's a button here and a tube at this end. So what you do is you bring it down to the solder and you heat it up with your soldering iron, and then you press the button and it sucks the solder off the board. So for the next part of the exercise, I want you to take all the resistors off of your board. And we're going to do that using the desoldering pump or the solder sucker. So for this part of the exercise, we're going to take our board. I'm just going to weight it down with my needle nose pliers here. I'm going to hold the desoldering pump in my left hand. So push the plunger down and put your thumb over the button, and then over the first connection that you want to desolder, place the pump on one side. Now it's always good practice to clean off your soldering iron tip and bring it in. You want to melt the solder. You want to bring the pump in on the other side and right over the top and press the button, and it should suck the solder right off of the pad. Sometimes you don't get it right the first time, so you have to bring it in, reheat it, and suck it off again. Now please notice that when I press that button, the soldering pump does move quite violently. So it might take you a few tries to get it the first time. So bring the iron in, heat it up, put the pump over top. Now don't get the tip of the pump too close to the soldering iron, because the tip is plastic and the iron will melt it. So clean off your tip, go for the next one, recharge the pump, and suck. Now I've desoldered these two pins, and you can see that there's still solder left on the pad. Right, so once you apply solder to these copper pads, solder always stays on them. So I've tried to suck the solder off. The pins should be able to wiggle a little bit loose. Sometimes they do, sometimes they don't. If I turn the board over, the resistor should come free. And you can see that I pulled one end free. The other end is coming free, and out comes your resistor. Sometimes it takes a couple of tries, so don't get discouraged with your first one. So then I want you to turn your board over and desolder all the rest of the resistors. So I've desoldered the board, and you can see here's my pile of resistors that I'm going to save for later. So one of the things that I wanted you to notice about my board is you can see where I've desoldered the resistors from. All the pads are shiny. And then every so often you see, whoa, where'd that pad go? So I've got one there, one there, one there, one there. So as you look over my board, you can see every so often a pad has gone missing. One there. So when they make these boards up, these boards are typically made of fiberglass. The material is a glass fiber with a resin poured on it, so it's really like a glue, and it makes a solid fiberglass board. To the board, a coating of copper is applied. Now it's kind of just poured on. Right, the board is really kind of a plastic, so the metal doesn't really bond to a plastic. It's more like a glue, and you notice when a glue breaks, right, it always breaks along the glue line. So when we heat a pad up, it becomes damaged, and if we damage it too much, the pads bond, right, the copper bond to the plastic just lets go and the pad just falls off. So while this entire exercise probably took you about an hour to accomplish, you can see that you didn't accomplish it without doing some kind of damage to the board. So this is a good lesson for you, so that when you come along and work on one of your own printed circuit boards, you can see that you can damage them trying to put parts in, take parts out. So once you've taken all your parts out, take this up to your professor to sign off to say that you have desoldered your board. Now we're going to start exercise 2. Now on exercise 2 we're going to use the smaller board and a couple of ICs. So this is the smaller board, and I've engraved my name. What we're going to do is we're going to solder on a couple of ICs. Doesn't matter if you've got larger ICs, smaller ICs. You may even have 3 in your package. When you have a brand new IC, the legs bend out on a bit of an angle on either side, so they will not fit into your board. So what they recommend you do is you take your IC, and you can see I'm holding it between my 2 thumbs and fingers. Just put it down on the bench and give it a little push to kind of straighten those legs up so they go straight up and down. And then we're going to find a spot. Try and find a kind of a central spot. Now if you can get one set of legs in on one side, sometimes you just have to push it and it will slide in. So you have to get all those legs to line up with all those holes. And sometimes they won't, so you have to put it back on the bench and bend them over a little bit more, and then try putting it in your board again. There we go, that fits better. So clean the tip, add a little bit of solder to it, and then we're going to come along here and we're going to solder the pins in. So the idea is we're going to heat up the pin and the pad, bring the solder in from the other direction, watch it melt, and run the tip up the lead. Now these leads are very short, so you don't have a good runway for it. I don't like to solder every pin one after another because the heat builds up in one area of the IC, so I solder every second pin. So I'm going to come in, solder the second pin, and then I'm going to do the third pin, and then I'm going to do my last pin here. So notice I've soldered every other pin, and then I'm going to come down on the other side here and solder in that pin, and then this pin, and then solder in the next pin. Now at some point you're going to look at your tip and say, well, that tip's looking a little dirty, so clean it off on the sponge. Add a little bit of solder to the tip, and then continue on soldering your pins. Okay, so like I said, I like to solder every other pin so the heat doesn't build up in one area, and then I come back and I do the in-between pins. So do that one, and then that one, and then that one. Now I'm going to give you one precaution here. Make sure that your IC is flat on the printed circuit board before you solder in all the pins. Okay, so when I turn the board over, the IC should be flat to the board, because it's a real job to come along and try and desolder all those pins and try and push the chip in afterwards. So once you're happy you've done that, you can show that to your professor, have him check it off, and then we can put the second IC in. So to do the second IC, we got to bend the legs over again, and bend the legs over again, so that the legs go straight up and down. That one's a little too far, so just come back and bend it again. There we go. Now it's very important that when we put ICs into a board that they face the same way, right? So on here we can see we have the smiley face, and we have pin 1 on this side. So on this IC here we want to do the same thing. It doesn't have a smiley face, but it has a little dot over pin 1. So we want to line them up so that both ICs are facing the same way. So I'm just going to move it over to somewhere around here on my board, and then try and get all the legs in the holes. Now it's very important the leg goes in the hole and doesn't bend up underneath the IC. So when you point it this way, you should be able to see underneath it. Make sure it's flat to the board. Turn it over. Make sure that all the legs come through the holes. Some students get so excited about soldering their parts in, they come along and they say, oh, the pin's missing. Well, it bent up underneath the IC, so you have to check to make sure that all these pins went through the holes before you solder it into place. So I've got my IC in, and I've checked to make sure that all the pins are in, so I'm going to clean off my tip. Bring my tip in, add a little bit of solder to it, and then I'm going to do the first pin, and then I'm going to do the next one over, and then I'm going to do the next one over, and then I'm going to do the next one over. Then I'm going to come to the next line. And before I do that, I just want to tip it over, check, make sure that it is flat to the board. Okay. Doesn't hurt to go back and forth and check these things several times. So I'm going to solder in that tip looks a little dirty. I'm going to clean it off. Put a little bit of solder on the tip, and then heat up that pad, that pin. Run the tip up. Run the tip up. Run the tip up. Run the tip up. And then I'm going to go in and fill in the ones that I haven't done. And keep checking your tip, make sure the tip is clean. So make sure all your solder connections are complete. Both side C's are in the board, flush to the board. Take this up, show it to your professor. Okay, so now that I have both ICs soldered into the board and your professor's seen it and checked it off, we now want to take the ICs out. Now we could use the desolder pump, but I'd like to introduce you to the solder wick, or what we call desolder braid. So we open it up and we pull a piece of braid out. Now this gets very hot in a hurry. Okay, so what we do with the braid is we put it right down on top of the pin. Then we bring in our soldering iron, and I clean off the soldering iron. We don't want any solder on the soldering iron. Okay, the braid has flux in it, so all we're attempting to do is to heat it up. So we heat it up, and then it sucks the solder right the way off of all the pads, and you can see I'm just slowly dragging it down. So you can see that it sucked it completely off of the first two pads, and now I've got to take it off of the other pads. Now I have the braid here, and you can see that the solder is in the end of the braid, so you have to take your side cutters, come along and cut off that piece with the solder in it. Remember to put your fingers over it so it doesn't fly across the room. Okay, then put it back down. Clean off your soldering iron tip. Reheat the braid. So bring the braid back in, reheat it up, wait for the solder to start to melt, and then just slide it across and suck it off of the next few leads. Okay, so now you can see I've still got a little bit of solder around that one pin right there. So I've got solder in my braid. I need to cut it off. And then I'm going to come back to this pin. I'm going to put the braid on the other side because I can see that there's more solder on the other side than this side. So I'm going to reheat that braid. And it sucks the solder off and just slide it off. Okay, so that's one side desoldered. Now I'm going to desolder the other side. So before I do that, I'm going to cut the little piece off that has the solder in it. And then I'm going to come along and desolder the other side with the braid. So I'm going to line the braid up with the pins. Clean off my soldering iron tip. Bring it in, heat up the braid, and slide it along. Okay, you can see it doesn't take all the solder off all the pins, but it does leave solder in the braid. If I was to come along and use the next part of the braid with that solder on the end, the heat is going to travel along the whole piece of braid and start to melt that solder, and that solder could melt onto the board and stick to it. So when I pull the braid across, it could end up pulling these pads off. So that's why you always need to cut the braid off that has solder in it. And then come along, clean off your tip, reheat the braid, and then just slide it along slowly so it sucks all the solder off those pins. Remember, this is going to be very, very hot, so you need to hold your fingers further down. If you hold your fingers too close while you're doing this, you're going to burn your fingers. So hold it a little bit further away. And as soon as it gets some solder in there, snip the end off with your side cutters. Now, if you've managed to get all the solder off of there, you should be able to push your IC through, and it should just fall right off. And you should be able to reuse that IC. So they can go along and do the same procedure with the other IC. Now, if your IC won't come out, don't force it. You may need to go back and run the braid over another pin that may be stuck in there. So you can actually wiggle the pins a little bit to find out which ones are stuck. You may need to run the braid down the other side of the pins. So clean off your tip. Run the braid down the other side of the pins. Make sure you leave time for this to heat up, or else the solder won't melt. So I can see some more solder got into the braid. So I'm going to cut that piece off. Turn it over, see if I can pull my IC out. This time it comes out. Doesn't look too bad. Now notice, all these pads are okay, but this one's missing. So even with the solder wick or the desolder braid, you could still end up damaging the board. So take your desoldered board up to your professor for him to sign it off. I know the exercise seems a bit monotonous to just keep going along. It probably took you about an hour and a half to do those two boards, but the practice will help you when you do your next project.